is click on raise hand, then in the question area, write down the question that you may have, and at the end of the webinar, I'll go through the questions and answer them to the best of my ability. Again, click on raise hand. In the question area, write down the question. When you finish writing down the question, click on send, as shown over here, and then I'll try to answer the questions as best as I can at the end of the webinar. Okay, now before I actually start, what exactly is HSR and HSM? What's the whole idea behind it? Well, basically, it's taking a geometry, and your geometry in this particular case is the part itself, and you're saying like this: here's my part, here's my tool, go machine it. That's all you're really doing if you think about it at the end. You're just taking your part, your geometry, your target in this particular case, your tool, and you're just telling the program, go machine the part. Now it knows the geometry, it knows the part, and it knows not to go into the part itself. It knows only to machine everything around the part. Now, of course, there are other parameters that we'll be dealing with that we know about, that we have to work on, and that's exactly what we'll be showing you. But in general, that's really all you're doing. You're taking a part and you're saying, here's my part, here's my tool, go machine it. So let's start and see exactly what we have to do in HSR. HSR, as I said, is the roughing part of the machining of HSM. So we're going to start by this particular part that we see on our screen over here. And as you can see, this part is a mold of some sort, where this part is actually a core actually sticking out of the top of this area over here. Plus, it's also it's sunk in within this area over here as well. If we take a look at the stock is exactly this, what you see on the screen, a block around the part itself. In this particular case, it's exactly the exact same size of the part itself. We'll start our first operation in HSR, and we'll go into our option of HSR as shown on top over here. And we'll start off with our technology. Now, as you know, all of the operations over here follow the exact same rules as in the rest of our program. We use geometry, tools, boundaries, in this particular case, and passes and links. But this is the basic format that we have in the program. Now, as far as the technology goes, we have several different types of technologies that we're going to that we can work on. What we'll be discussing today is the technology of contour roughing, rest roughing, and the new option that we have here called HM roughing, which is introduced in SolidCAM 2013. So we'll start with contour roughing. Okay, now as you can see, the geometry is already chosen into here, so I don't have to pick my geometry. My geometry, excuse me, is the target itself as shown over here. Next, we'll choose a tool, and in this particular case, I'm going to choose a 20 millimeter end mill as shown over here. And we have our tool data, such as our feeds and spin rates. I'll select the tool. One thing we should know before we go on is that next tool, after we've chosen the tool, we have a separate data over here. Let's just take a quick look at this data field that we have. You can see, first of all, we have our cutting speed over here, our spin rate, and then we have our link down and link up and rapid. The link down tells you exactly the feed that you're going to have as you approach into the part. The link up is the feed that you'll have when you're going out of the part. And we have a rapid option. This rapid option is not for G0, because G0 is actually controlled by the machine itself. This rapid is for, there are times when we move from one place to another with the fastest possible speed and the shortest distance. In those cases, it uses the option of G1. So that type of rapid will use this, whatever this value is over here. And the value that's over here comes automatically from your machine ID. Okay. Going back to tool itself, note there's one other thing that we have inside HSM and HSR and HSM as well, is something called the holder clearance. This allows for the holder to actually be checked that it doesn't come in contact with any of the stock. So in this particular case, so in HSR and HSM, when we have our holder clearance, you can actually go deeper into a pocket without worrying about hitting the actual material on the side because we have the holder clearance check. We'll take a further look into this, by the way, in one of our next webinars in HSM, where I have an exact example that will actually show how this works. Okay, next we have our constraint boundaries. Now, in HSR and HSM, we have to tell where on the part we want to work. However, if we're working on the entire part, the default is created automatically, where it automatically creates the boundary around the part. And according to what's written over here, in this particular case, automatically created box of the target geometry, where it creates a boundary, if I take a look from the top view, according to the boundary of the part itself. And it'll work there only. I also have the option of auto-created box to stock, the box of the stock. But in this particular case, the stock and the target are the exact same size. So it really doesn't make a difference in this case which one I chose. Okay, now let's go into passes. When we go into passes, we have our fields that we have to fill out here. Our first field is our wall offset. And note again, just like in any part in SolidCAM, and especially you'll especially note this in HSR and in HSM, when you go into a field, you get a diagram on the side showing you what that field does. For example, we went into the wall offset. As you can see, it's showing a offset from the wall. I'll put in a value right now of 0.5 millimeters. And we also have a floor offset. Note, when I jump to my floor offset, it automatically takes the value of what was written in my wall offset. Now, how does this know how to do that? This is go a little history into the part itself. Every single field that we have over here, without any, with every single field, no matter if it's this field or this field, any of these fields over here, if I right click on it, we have view parameter information. Let's do it on this particular option over here, the floor offset, and we have view parameter information. If I click on view parameter information, first of all, it'll show me any formula I may have over there. So in this particular case, the passes floor offset has a formula of tool thickness. Whatever the tool thickness was, in other words, the addition that was added on from the wall offset, that is what the value is over here automatically. By the way, if I go into here and click on these arrows over here, you'll note that it'll also give you an explanation of what that field actually is. This is true not only in this field, but in any field I click in, whether it be the tolerance field, step down field, every field you have an explanation of what that field does. So if you don't remember what a field does, just click on the field and you'll see it over here. I've actually right click, view parameter information, and you can see that as well. Now, let's go back to my floor offset. It gave me a value of 0.5. Okay, what if I change this? If I want, I can change it 0.2. Okay? If I go into my view parameter information, you'll note that there is no more formula over here. Because once I write something in there, I'm overwriting the formula that's part of that field. If I want to bring back what the original was supposed to be, the default value, all I have to do is right click and we have reset this parameter. If I do that, I'll get back what I have over here and my formula comes back. The same is true with any other option. For example, tolerance. The tolerance usually, by the way, if I have this as 0, wall offset, is a small tolerance, 0.02 of a millimeter. When I set this at 0.5, you'll note the tolerance automatically grows, because if I'm using an offset of 0.5, I don't need a tight tolerance. Now, of course, I can change this. If I want, I can say 0.3528798. Doesn't make a difference what. But if I want to go back to the default, by the way, right click, reset. By the way, if I do view parameters, you'll see there's no formula there. Right click, reset this parameter. We're back at what it was supposed to be. Okay, let's continue now with the actual field itself. Step down, how much do I want to step down each time? We're going to go down every 4 millimeters. And then we have our minimum offset. The minimum offset is a value is actually taken from the tool itself. It's half the diameter of the tool. That's how the minimum amount that is actually going to step over as it does its profile operation. Now, next, we have our maximum offset. Note our maximum offset is actually grayed out. We recommend not to change this. This is why we grayed it out. However, if you decide that you want to change its value, you can always open it up and change your maximum offset. Now, as I said, we have our step down and we have our offsets, and in this particular case, we also have something else here called detect core areas. Detect core areas allows you to work from the outside in wherever there is a core area, wherever there's an area that can be machined from the outside in, such as our part itself as shown over here. Now, okay, we're basically done right now. We have our Z-top, by the way. The Z-top is how much material, where we're starting off from the top. Note it gives you 0.5 millimeters. That's because we have a floor offset of 0.5. So it actually starts 0 plus whatever the offset is. Now, let me do save and calculate now. Note, when I do save and calculate, now, by the way, in 2013, we have parallel calculations within the operation. We can it can actually calculate several parameters within one shot, so the calculation of an operation goes a lot quicker. Okay, let's run a simulation, and we'll first run it with our host CAD. You'll note that first it worked all the way from, we'll slow it down over here. It worked from the outside in, and note it finishes the first level and then goes to the next level, and then it goes down to each step, and never does it ever go up to its top level. We can see it over here, its start level, its clearance level. Only at the very end does it go back to its clearance level. What actually happens is it's always taking the shortest path when it goes from one area to the next. Let's go all the way now to the very end, and you'll note that at the very end it went back up. Now we'll run this again with with Solid Verify. Sorry. You'll note again that it machines everything from the outside in, and these areas it just went down the way it also machined those areas as well, going into those areas. In other words, not going from the outside in, but in this particular case, it actually worked like a regular pocketed area. Note there are areas that could not be machined. For instance, there's a whole area inside over here, a whole slot that was inside over here because the tool is too large. Also note that the holes in the part, there are large holes in the part that were not able to be machined, that were not machined. That's because the hole itself is 21 millimeters. The tool is 20 millimeters. Plus we have a 0.5 millimeter offset, so that's also 21, so there's no room for the tool to go in there. There's something else that controls that it doesn't go in there as well, and that's in our link. In our link we have something called minimum profile diameter, and I'll point that out to you in our next operation to show you exactly what that does as well. Okay, so now that we've finished this operation, our next operation is to do another operation of roughing, but this time using a smaller tool and only working in the areas where this particular operation was not able to work. So if I were to go at the bottom over here, I'll just do save and copy. We have a new operation based on the first operation, and instead of contour roughing, I'll use the option of rest roughing. If I use rest roughing will only work in the areas where there is material left over, and it doesn't make a difference what operation I had before. If it was an HSR operation or even a regular pocket operation of any kind, or a drilling operation, anywhere that this material does not, that there are any area where it has no material, it won't machine in those areas. Okay, let me go into my tool now. I'm going to choose this time a smaller tool. This time I'm choosing a tool of 12 millimeters with a 2 millimeter radius at the bottom. In other words, at the very top it's 12 millimeters, but the very bottom of the tool it's only 8 millimeters. Okay, select. Constraint boundaries, I'll leave it exactly the way it was. If I go into my passes, since I did save and copy, these values are kept. In the previous versions, these were automatically put to 0 when you changed it to rest roughing. Now when you change it, these values are kept exactly the way they were. Okay, step down. This time I want to step down every millimeter. And note, my minimum offset is set at 4. 4 being half of the 8 millimeter diameter at the very bottom of the tool. So this way, by the way, by doing that, it guarantees that there will be no cusps left at the floor of the part itself. Again, I can use the tech core area, and as I mentioned before, we have a minimum profile diameter of 8.8. Again, I'll explain it to you in a few moments, but first, let me actually run my simulation. Well, actually first calculating the part itself. Okay, the calculation is almost done. Remember now, it's actually calculating each step down and checking the material that's left over. Note that it's going to start working on the entire, however, it's only working in the areas where there's material to be taken off. It's not working in the air around here, just in these areas. Plus, it's totally machining out these slots over, this slot over here, which was not able to be machined in the previous operation because the tool is too large, plus this pocket over here. Now, note also that these holes, it started going into the holes up until a specific point and then stopped. Now, let me explain to you exactly what happened over there, why the tool actually didn't go into the entire hole, even though the tool itself is 12 millimeters and the hole is 21 millimeters. What's happening is as follows. If we go back into our operation, into our link, I'll explain to you exactly now what the minimum profile diameter does. The tool that I'm using in this particular case is a 12 millimeter bullnose tool with 12 millimeters on top and 8 millimeters on bottom. If I take this value, 8.8, and add it to my 12 millimeter diameter, that would give me a total of 20.8 millimeters. If I add, like I said, the hole itself is 21 millimeters. This came out now to 20.8. However, we still have an offset of 0.5 millimeters, so this value is not allowing the tool to go all the way in. But you remember that it actually spotted a little on the bottom. That's because the bottom of the tool is 8 millimeters in diameter. So if I add 8 to 8.8, we have 16.8, allowing for a little bit of the bottom of the tool to actually machine a little bit of this. If I want to prevent that, I can just up the value over here. Let's put this at 12 millimeters. Save and calculate. And if we take a look now at the machine, at the tool pass, at the machining, you'll note it'll work in all of these areas just as before. However, when it gets to those holes, as I showed you before, it won't even spot on them. It won't touch them at all. So this actually can control areas where large areas where you don't want the tool to go into, just by upping this value or making it lower. Putting it back at the default, reset this parameter, it's 8.8. Okay, again I'm going to do save and calculate and let it finish its course. Now, what happens if the part itself was pre-machined? For example, let me go into these operations that I've done over here just now, suppress them, and I'll open up this one that I've done before that I prepared myself with, of a operation that left my material looking like this. In other words, this is how I'm going to receive my material. How do I proceed from this point? Well, all you have to do in this particular case, I'll start a new HSR operation, and I'll start immediately with rest roughing. I'll take my tool of 20 millimeters. I'll leave everything the way I had it before. I had this at 0.5. This one here, 4 millimeters. Detect core areas. And if I go into my edit passes, and we have here, it's set automatically, it's set to define, to look at the stock definition automatically. So whatever the stock was left over, that's exactly what it's going to work on. Let's do save and calculate. You can see my stock over here, and now you'll see that it only works on that area itself. Now, and all I have to do right now is just do save and copy again. Leave everything the way it is, even leave the rest roughing, and use a smaller tool. By the way, I can actually go down and do another rest roughing if I wanted to use even a smaller tool after that. Okay, I changed my tool. Constraint boundaries, passes, have this at 1 millimeter just as before. Note again my edit passes we have over here, we have it automatically. If I click on show, it'll show you exactly what the material it's actually going to be working on. You can see that it's only going to be working on this material. So it recognizes the material that's left over. Do the calculation. Okay, just a moment. Okay, and run my simulation. As you see, it's just working exactly the way it needed to be. And again, like I said, if I needed even a smaller tool after this, I just copy it again and just do another operation. Okay, next. We're going to go to another operation. And I want to start explaining what HM roughing is. For that, I'm actually going to load a different part. Let me close this part. We'll go to SolidCAM. Okay. In this part, I'm going to actually demonstrate working in 3 different areas. One, an area where we have a pocket or a cavity. 2, an area where we have a core, okay, where we have a boss sticking out of the middle. And 3, an area that can actually, it's not actually a pocket or a core. It's sort of a combination. It's sort of an area where it's an open type of pocket. Okay. We'll go into our operations that I've created over here, and I'll open up the first one. The first one, I want to actually work in this area. I'm going to use the option of what we call HM roughing. By the way, I'm starting to find that if I use HM roughing, I'm almost not using any of the other types of roughing, except for the rest machining anymore. I'm practically using this almost all the time now, in general. Okay, I have my HM roughing, my target, my tool, using a 12mm end mill. The heart of it is in our passes. In our passes, okay, I'm going down every 5mm. And note this option over here, step over type. And in this particular case, it's set at cavity. We have 3 different options: cavity, core, and HM spiral. As I said, in this particular case, I want to work on the cavity. If I go into my constraint boundaries, you'll note that I'm only working in this area itself. Okay, let's run our simulation, and you'll note, I'll run this slowly, the tool is actually just working only in that cavity area, going down in the cavity, exactly in the middle, and working its way out, working its way from the middle, just like any pocket type of operation. It's a very simple operation, but a very efficient way of working. Now, just to show you a little bit of a difference, what would happen if I worked in that area, say core, for example. Let me do the quick calculation. Note, it tries to work from the outside in, but it can't. But it doesn't go in exactly in the middle. So this is not necessarily the most efficient way of working. But working with the option of cavity, as I showed you before, is the best way to work in a closed pocket area. So all I have to do is choose cavity, and it'll work exactly that way as we see over here, going exactly in the middle and working its way down. Okay, in my next operation, I want to work on this area over here where I have an actual core sticking out of the part. Taking a look at the operation itself, again, HM roughing, the exact same tool. My constraint boundaries in this particular case is this area over here. And in my passes, this time I chose the option of core machining, working on the core. There's something else here called, by the way, step down type constant and constant flat, but I'll explain that to you in our next operation that I'm going to show you. Again, the step down is every 5 millimeters. If I run my simulation this time, take a look at this area over here, you'll see that it's actually working from the outside in towards the actual core. Note that when it gets to the corners where it can't actually continue its tool path in certain cases, it actually picks itself up by using the shortest possible tool path and then going down in the next area. So this is actually working, again, the most efficient way for a core. Now, in my last operation over here, we're going to be working again on the same part, same tool. My constraint boundaries in this particular case is this area as shown over here. This area over here. Note that's actually being allowed to come in from the outside over here. If I go to my passes, this time I'm going to use the option of HM spiral, and let me first start with a step down of 7 millimeters. And I'm doing 7 millimeters on purpose to show you something. I'm doing the option over here now of step down type constant. We have constant plus and flats. The constant will do the following. It'll go down every 7 millimeters. Doesn't make a difference if there's a step in the middle or not. It'll go down exactly 7 millimeters each time. Making a quick calculation, and then we're looking at the simulation itself. You'll note that the tool path, if I look at it from the side over here, goes down every 7 millimeters. This step, this step, this step. The next step down here, note it's this particular case, it's leaving a lot of material over here. But I told it every 7 millimeters constant, so it's exactly what it did. Also note the tool path is actually really nice. It's going from the outside, like a regular offset cutting with a contour cut off on the walls itself. But I still want to deal with this step. What we can do here is as follows. By the way, let's take another look at the simulation. I want to use this time solid verify simulation. And if I take a look on the wall over here itself, you'll note every 7 millimeters over here. Very easily noticeable. Now, this time though, however, I'm going to change my constant to constant and flats. What this will do is it'll go down every 7 millimeters on the part, but when it sees a flat area, such as this over here, it'll also stop and clear that area as well. Let's take a look at the simulation. This time, you'll note that it's working a step down every 7 millimeters, but when it saw this flat over here, it stopped and cleared off this step over here plus this flat over here as well. So now it does not have that excess, that a large amount of material left over for your finish cut. If I take a look at it at the host CAD, you can see that the tool path, and I'll try to zoom in this area over here, the tool path actually covers this area over here now as well, which it didn't cover before. Okay, that's all I'm going to be doing in this session. And I'm going to go now into the questions that some of the people have asked over here. By the way, again, our next week's webinar will be on HSM Part 2, which is HSM, and Part 3 will be the week after, also on HSM. There was a question here, there is no simultaneous fourth axis HSR. HSR is a 3-axis operation does not work simultaneous in 4 axes. In fact, I'll even go better than that. When you're doing an HSR operation, what HSR does is actually doing think of it as a regular pocket operation, where every single time it steps down, it looks at its outside border and its inside borders and works like a pocket on that area, like a regular. In other words, it only works in X and Y in those particular cases. In HSR, works only the working time is only in X and Y. There is no simultaneous in HSR. HSM, however, HSM is 3 axes, and that does work simultaneous. But what you need, if you want to do a statue which is like a 5 axis, that you need 5 axis, 5th axis module, which is not HSM, which is actually it's our simultaneous multi-axis machining, which will have a different webinar on that. There is a way, however, if you do have the option of 5-axis simultaneous or multi-axis simultaneous multi-axis machining, to change an HSM operation into a 5-axis. But we'll get into that in a different webinar, not this one. Okay, there's a question of what options are there for manually select stock models for edit passes in HSR. Let's go into, I'll open up the previous part. And we'll just open up one of the operations over here, which is arrest roughing. It doesn't really make a difference. Okay, but I'll open that up. If I go into passes, edit passes, right now it's set at automatically. If I click over here, we have by selected operations. Okay, but let me go back and actually open up the roughing operation. I'm going to actually unsuppress it for now, and we'll actually open it up. When I go into passes and we go into edit passes, if I choose to do edit using surfaces, we have the target geometry. We can do auto or updated stock. We can also use stock FCT files and stock STL files. So you can use these different types of stocks that were created beforehand to work on only that stock. By the way, by actually doing this, what you can see over here is that you can even do a rest roughing operation in your regular contour roughing by just choosing the option of edits using surfaces of auto updated stock, and it'll work the exact same way as in rest roughing. Okay, now as far as there's a question about, again, going back to the simultaneous. When you have HSM and HSR are 3-axis operations, period. Now, when you're doing a model or modeling something, usually when you first rough out most of the material with the HSR, and you don't need anything simultaneous at that point. You can do HSR from one side and then flip it to a different angle and then machine more. However, for finishing you can do, but you must have the module of. You must have the capabilities within the SolidCAM that you've purchased to have the simultaneous machining, the multi-axis simultaneous machining. If you have it, there is no problem doing a finish with HSM, because that HSM can be converted into a simultaneous motion as well. And in fact, in the last webinar that we have on this series, I'm going to try and show you that as well, where if I've created an HSM toolpath, how I can actually change that HSM toolpath into a multi-axis pass instead. Obviously, though, like I said, you must have that option open for you inside SolidCAM itself in order to be able to do that, to do simultaneous movements. But yes, the HSM, you can, if you have that option, you can use HSM, and it can be put into it can be actually made into a multi-axis simultaneous machining operation. Robert, at the next time we have a webinar, I'm going to prepare something to show actually with the obtaining STF and FCT files. A quick overlook on how you can do that is, let me just go out of here. If I were to run, let's say I'll simulate this operation over here using Solid Verify. I'll just give you one particular way of doing it. I'm going to run my simulation over here. I can go into this point over here at File, Save Machine Stock to FCT, Save Machine Stock to STL. That's the easiest way to do it. And then you'll have your stock then you can have your stock already there. And then later on, once you've saved it, you can actually refer to it when you're doing your rest roughing operation, or your roughing operation, by opening up the option in passes, edit passes. Obviously, I was using contour roughing to do that. Edit passes, and then choose your FCT or STL file, which is made from the particular operation over here. As far as rest roughing goes, let me see that for a moment. It's not available in it's not available in rest roughing. However, if you're using it, if you want to use it as rest roughing, all you have to do is just do another contour roughing, and it'll act just like rest roughing, because it'll be working only on that stock itself. The contour roughing will be worked exactly like rest roughing. Okay, thank you very much, everyone, for joining the webinar. Again, next week we'll have this webinar again on HSM. Sorry, not again. We'll have as part 2 of the webinar on HSM. One more note: I have recorded this webinar. And if we go into our website, you can find them. I'll just show it to you over here quickly. If you go into webinars, webinar recordings, you can see the list of all the webinars that I've recorded already. And by the way, the last 2 and this one as well, if I were to choose to view this webinar, for example, we also have an option of downloading the film as well. So this way you can always view the film at a later date, also in high definition. Okay, thank you very much, everyone, for joining the webinar, and see you again next week.